Good morning. Today we are going to see the Unit 2 of Ad hoc Wireless Sensor Networks. The first topic is Challenges for Wireless Sensor Networks. Major issues and challenges that affect the design and performance of a wireless sensor network are as follows. Energy efficiency, quality of service, security issue, deployment, node cost, limited bandwidth, scalability to large scale of deployment, fault tolerance, multi-hub communication, and design constraints. Energy efficiency, the first and often most important design challenge for a WSN is energy efficiency. Power consumption can be allocated to three functional domains: the sensing, communication, and data processing, each of which requires optimization. The sensor node lifetime typically exhibits a strong dependency on battery life. The constraint most often associated with sensor network design is that sensor nodes operate with limited energy budgets. Typically, sensors are powered through batteries which must be either replaced or recharged when depleted. For non-rechargeable batteries, a sensor node should be able to operate until either its mission time has passed or the battery can be replaced. The length of the mission time depends on the type of application. Then QoS, quality of service. Some real-time sensor applications are very time critical, which means the data should be delivered within a certain period of time from the moment it is sensed. Otherwise, the data will be unusable. So this must be a QoS parameter for some applications. Security issue. Many wireless sensor networks collect sensitive information, especially for military applications which carry sensitive data. The remote and unattended operation of sensor nodes increases either exposure to malicious intrusions and attacks. Further, wireless communications make it easy for an adversary to eavesdrop or censor transmissions. For example, one of the most challenging security threats is a denial of service attack, whose goal is to disrupt the correct operation of a sensor network. Deploying and managing a high number of nodes in a relatively bounded environment requires special techniques. Hundreds to thousands of sensors may be deployed in a sensor region. There are two deployment models at present. One is static deployment, another is dynamic deployment. The static deployment chooses the best location according to the optimization strategy. The location of the sensor nodes has no change in the lifetime of the WSN. Dynamic deployment throws the nodes randomly for optimization. The node cost. A sensor network consists of a large set of sensor nodes. It follows that the cost of an individual node is critical to the overall financial metric of the sensor network. Clearly, the cost of each sensor node has to be kept low for the global metrics to be acceptable. Depending on the application of sensor network, large number of sensors might be scattered randomly over an environment, such as weather monitoring. If the overall cost was appropriate for sensor networks, and it will be more acceptable and successful to users which need careful consideration. And limited bandwidth. Bandwidth limitation directly affects message exchanges among sensors, and synchronization is impossible without message exchanges. Sensor networks often operate in a bandwidth and performance constrained multi-hop wireless communication medium. Presently, wireless communication is limited to a data rate in the order of 10 to 100 kilobits per second. Scalability to large scale of deployment. In some application, tens of thousands of sensors might be deployed at any time. Numbers of nodes can be increased or decreased. A synchronization scheme should scale well with increasing number of nodes and or high density in the network. Fault tolerance. In a hostile environment, a sensor node may fail due to physical damage or lack of energy. If some nodes fail, the protocol that are working upon must accommodate these changes in the network. As an example, the routing or aggregation protocol, they must find suitable paths or aggregation point in case of these kinds of failures. Then multi-hop communication. The need for multi-hop communication arises due to the increase in the size of wireless sensor networks. In such settings, sensors in one domain communicate with sensors in another domain via an intermediate sensor that can relate to both domains. Communication can also occur as a sequence of hops through a chain of pairless adjacent sensors. And design constraints. The primary goal of wireless sensor design is to create smaller, cheaper, and more efficient devices. A variety of additional challenges can affect the design of sensor nodes and wireless sensor networks. WSN has challenges to both software and hardware design models with restricted constraints. Thank you.